Let x follows the Bernoulli distribution for theta. Find the Fisher's information. So like we said, today we are talking about the Fisher's information. For we to get more of this, you need to subscribe to this channel. So how do we go about this? Solution. We first recall that the Fisher's information states that you need to differentiate the first one all squared and take the expected value, and also the second here there is no square, but there is a negative sign here. So whenever this happens, you solve for your Fisher's information. So the first thing we do is to get the first one. And this first one, if you open this, it means the differential with respect to theta mean f of x all squared. And be reaching this way. So this is the Fisher's information. So since we are given this, if this is our function, we take the mean function of this first, which is this, to give x mean theta minus, okay, if this is coming over to this place, it gives us 1 minus x mean 1 minus theta. So this is what we get. We want to write it this way. For this, the first differential, that means this. See, by first derivative, that means the whole of this first. We have the expected value of to differentiate this, we get x all over theta. If we differentiate this, we get plus 1 minus x all over 1 minus theta. Since we are differentiating with respect to theta, we get this times 1. Sorry, times, we are differentiating with respect to theta, we get times minus 1, which is equal to x all over theta minus 1 minus x all over 1 minus theta. So we cross multiply to give us x theta 1 minus x all over theta 1 minus theta. If we expand the brackets, we get x minus x theta minus theta plus x theta all over theta 1 minus theta. So this will cancel this. You will now be left with x minus theta all over theta 1 minus theta. So if you compare it with the Fisher's information, you have the expected value of x all over theta all squared. So we take the expectation of this. This is our answer with this. So we take the expectation. It means the expectation is equal to the expected value of x minus theta all over 1 minus theta all squared. So we move over to this place. Here, if you take the expected value, the efficiency information here for the first derivative, equal to the expected value of x minus theta all squared all over theta 1 minus theta. So we have theta squared 1 minus theta squared. So we recall that this is our variance of x all over theta squared 1 minus theta squared. So all we have to do is that we recall that the variance of x is equal to theta 1 minus theta. So if we use it and apply here, we will get as our features information as theta 1 minus theta all over theta squared 1 minus theta, which will give us this can cancel this to give us 1 over theta 1 minus theta. So it means that the features information for the first derivative is equal to 1 all over theta 1 minus theta. For the first derivative, then, so by the second derivative, the features information is equal to the negative expectation of the second differential. So what are we differentiating? We'll be differentiating this. We are differentiating this function. So to differentiate that function, we use what is called the quotient rule of differentiation. This is the function we are differentiating. X minus theta x minus theta all over theta 1 minus theta. So we use v in u theta minus u dv all over the theta all over v squared. So what do we do? It implies that this v, let's say this is our u and this is our v. So if this is our u, this is our v, we have v to the theta 1 minus theta times the u all over the theta, the u all over the theta. So we differentiate this. This will give us 0 and this minus 1 minus u. This is our u. X minus theta dv all over the theta, dv all over the theta. This is 1 1 minus 1, which is 0. So we have 0 here, all over v squared. This is v, which is theta squared, 1 minus theta all squared. So it implies that we have this as theta 1 minus theta plus 0 all over theta squared 1 minus theta. So which implies theta 1 minus theta all over theta squared 1 minus theta. So this can cancel this. We will now be left with 1 all over theta 1 minus theta. So from the Fisher's information, our second derivative is equal to negative theta 1 minus theta. That is to say, that's our second derivative. That is to say, generally, that the Fisher's information for the first derivative and the second derivative is equal to the first one. We have it as 1 minus 1 over theta 1 minus theta, and the second one we have it because of this negative sign 1 all over theta 1 minus theta, which is the Fisher's information. So this is how we can resolve the Fisher information for the Bernoulli distribution.